Hi everyone, today to review my knowledge about multivariable calculus, I will use two methods to calculate the volume and the area of the Steinmetz solid, which in Chinese is called 牟合方盖. And it's just the common part of several cylinders, and today, since the common part of two cylinders is easy to calculate, today we will focus on the common part of three cylinders. And basically my two methods is in the two way. One way is to think how it looks like by its definition, because it's just so we could easily to draw its picture like and the second method is we just do not need to draw a picture. Since to be honest, firstly I look at this my brain couldn't come up with this kind of guys. So since actually I'm not a good at my ability of thinking my ability of thinking three-dimensional space is not good, especially in math. So we also could don't draw the picture and use the method of conditional equations to decompose the volume. And thanks to Dr. Bo Lin to let me know this. It's a very clever way, especially for me. I mentioned that I'm not good at thinking of the space in three-dimensional, and I think it's a good idea to use many methods to think of good math problems. Since the professor Du Wang, a very charismatic and responsible calculus teacher who has worked for our country in the area of math for at least 50 years, which was his target before, and he has realized his dream. He always says you should try to solve one problem many times with new methods to handle and understand knowledge better. So let's begin with today's topic. Firstly, I will use the basic, which is to draw the picture of the Steinmetz solid. This question just so we could draw the picture of it, and this is the cylinder. We just draw the one coordinate of it, and this guy is only the 1/8 of the whole. Right. Now I will decompose it. We could draw some special one, such as y equals to x, and we have this. D equals to x, we have this. Also, d equals to y, and we have this. Now, let's just look at it. This part is just the, 1, 2, 3, 4, 5, 6, the 1/6 times of it, and this is whole of it. So it's just this is the 1/48 times the whole volume. So firstly, we just multiply 48 of this volume, and to think of this, let's draw the picture of this guy, which is just the coordinates of y and x, and this is a 1/4 circle, and the area actually is this. And we could, if we have this area, we could integrate it by this part. This is the y equals to x, and this is z equals to x. So this part actually is z equals to y, equals to x. We get z equals to x. So we let this equals to d, which is area, and as we said before, we integrate by this d equals to x. And we could further write it as the polar coordinates. Actual is pi/4 to pi/2 is from 0 to r cosine theta r d theta. Since x is actually, this is theta, and this is theta, or cosine theta. And we have just the simple calculation. Okay, this is method 1. And since we also use this method to calculate the area of it, but next I will tell this specifically. Now let we see the second method, which is the conditional equation to solve it. Now let's define our d equals to x, y, z we let r equals to 2 here as an example. From these two guys, we know that if Similarly, if therefore our D equals to and another situation is x, y, z. All three of them are all less than or equal to square root 2. So just say our D equals to actually this is which corresponding to the second situation, and also which corresponds to this situation. Now it's easy to calculate this. It's just right. It's like that, and it's basically for this. We could write this as decompose this as a 3 part, which is and of course this corresponding to and which is corresponding to this situation. Okay, actually for this, because these three situations leads to the common volumes and they are equal, and so we 6 times. Now let's think of this. For this situation, no. Sorry for that. Since another situation for their volumes are equal, so it's just 6 times this. And for this, and from this equation we get from this we get right. So if we just regard the x as the only variable that needs to be integrated in our integral, and we consider this dy coordinates, and this area is actually equals to therefore this part So the main idea of it is just that these two parts don't have the cross part, and this makes the whole D. And for the error calculation, we could also draw this. Firstly, we calculate this, which corresponds to and this is just and now for the simplicity we regard r equals to 1. So this part is also, like we just said, of the whole area, and we regard it as A1, and A equals to 48 A1. Now let's calculate A1. This, the SXY is this is actually the circle. This equation is right. This is y equals to x. So this is just 1 over square root 2. And for this part, since it's not easy to integrate this part, let's integrate this. And A1 equals to